Welcome to our presentation in Lava, Long Horizon Visual Action Based Food Acquisition. In this work, a robot learns to plan sequence of action to clear the bowl and adapt to a variety of food textures. Traditional robotic assisted feeding methods have relied on preset strategies such as skewering, scooping, slicing, and bite transfer, which fall short in complex feeding scenarios akin to human feeding actions. Lava tackles the challenge of sequential bite acquisition for semisolid, deformable, as well as granular food by employing a hierarchical policy framework with visual feedbacks. Given the expert task demonstration for lower level primitives, which includes images and proprioception data, when presented with image of food in the bowl, our system employs ScoopNet to select high level primitives, which are deep primitive for cohesive food and wide primitive for non cohesive foods. Here with a bowl of tofu chunks, ScoopNet selects white primitive. Following this, TargetNet, our mid-level policy for white primitive, selects and aligns the target pieces based on their positions in subregions. Ball-guided scooping uses bowl support for the scoop, while align here refers to moving the target pieces to the center of the bowl for easier scooping. These mid-level primitives parameterizes low-level policy for action execution. Here Lava tackles an arrangement of white tofu. Initially, ScoopNet chooses a white primitive and TargetNet pinpoints the target tofu on the edge, which are then scooped directly. Pieces in the blue region are moved to the center before scooping. Notice how Lava adjusts when tofu slips from the spoon, ensuring each piece is expertly scooped up without breakage and spillage. With a bowl of cereals, ScoopNet selects deep primitive, while DepthNet determines the ideal scoop depth for efficient food clearance while parameterizing low level policy for action execution. Here's a demo of lava effectively clearing a bowl of cereals. The process is guided by DepthNet's depth assessment and expert driven trajectories, adapting in real time to ensure precise and efficient scooping. Now let's take a look at complete hierarchy of our lava's framework. These videos show how baseline methods without real-time adaptation fail, leading to spillage, breakage, and inefficient food acquisition. Now let's take a look at zero-shot generalization experiments. This video demonstrates lava acquiring fruit chunks. Given their irregular and spherical curved surfaces, apple chunks tend to roll or fall from the spoon. Lava adjusts to the fruit shape, ensuring better alignment and reducing the spillage. Now let's see soup with tofu chunks. Scooping both solid tofu and liquid simultaneously presents a unique challenge. Lava adjusts its strategy in real time. Even as tofu chunks float away due to fluidity of the soup, lava realigns and reorients to scoop effectively.